All right, hi everyone. I'm Peter, and together with my colleague Konstantin, we will be presenting the work of our colleagues and ourselves on expert users' strategies to detect email signature spoofing attacks. It is well known from the related work that signature spoofing in OpenGPG and S/MIME is possible. For example, these two emails look very similar, but the one on the right actually has a spoofed signature. And it is commonly believed that expert users can detect such manipulations. We wanted to investigate this closely, and for this, formulated 5 research questions. The first, we wanted to see which checks do expert users actually apply when checking the legitimacy of email signatures, and how do these form overarching strategies. Secondly, we wanted to see how useful are these checks that expert users perform, and connected to this, how successful are experts in detecting these attacks. And fourthly, we wanted to see whether the success actually correlates with other self-reported measures. And last but not least, we also looked at how users perceive this whole checking process. Now, unfortunately, I don't have time for all of these questions, but you can find all the details in the paper. For our investigation, we used a multi-step approach. The first step was a pre-study to find the most commonly used email client and email end-to-end security technology of our target participant group, that is, expert users. To that, we surveyed 23 participants at the Chaos Communication Camp in 2019 and found that Thunderbird and Enigmail were the most popular combination. We then created 4 emails with spoofed signatures based on the scenario, and these are based on the weak forgeries described in the work of Müller and colleagues. We will come back to these in more detail later in the talk. We then created our study design that would allow us to capture the participants' strategies and the reasoning behind applying these strategies. First, participants gave consent and then received explanations, and then followed the first questionnaire where we investigated the participants' expertise and the frequency of use of Thunderbird and Enigmail. And then came the main part of the study, where the participants had to assess 8 emails, that is the 4 with spoofed signatures and 4 with legitimate signatures, regarding their legitimacy in a think aloud setting. We created specifically an environment for the participants where they could use a real Thunderbird instance to do these checks, so that would have available all the features that they would have when they would do these checks in real life. To progress from one email to another, they actually had to close the Thunderbird, then a questionnaire regarding the legitimacy would be shown, and when they closed this window, a new Thunderbird instance with the next email would be shown. In the last part, we collected the RCBIS and SA6 scales, and after all that, there was a debriefing for the participants, and they had the opportunity to ask any questions. We piloted this design at the Chaos Communication Congress 2019 with 9 participants that were recruited using flyers and approaching them directly. And this test run actually allowed us to remedy a few issues with our emails, for example, specific headers that participants were looking for, and also allowed us to improve the Think Aloud setup. The main study was then conducted at FOSDEM, a European conference for open source developers, that was in February 2020, so that was pre-pandemic and in person. Participants were again recruited using flyers and approaching them directly. And overall, we could collect 25 valid sets of Think Aloud recordings and questionnaire responses. So what did we find from this data? We first looked at the checks and the strategies that expert users performed. And we found that overall, 23 different checks were performed by the participants with an average of 9.8 checks by each participant in their strategies. We then looked at the strategies, how they were formed from these checks. And on the right side here, you see the transitions that the participants made from one check to another. And I don't expect you to get a full grasp of this. The important message here is we had a high diversity in these strategies. And actually, we observed participants wandering around the UI, building their strategy only during our study. All right, and that's it from my side, and I will hand off to Konstantin.
Cool. Thank you, Peter. All right, the next question was how useful were these 23 different checks that we saw participants apply? Actually, how useful were they to spot the attacks we threw at them, right? So the first attack, was just an invalid signature, right? We switched some bits in the signature value, and this is what happens in Thunderbird. If you use the Enigmail add-on, you get this Enigmail bar at the top, which is yellow, and it says this is an unverified signature attached to this email, right? So regarding the checks, one very simple check would be to just look for this Enigmail banner that should pop up there, and if it's yellow or if it says something about an unverified signature, I could come to the conclusion that this email is actually not trustworthy because it has an invalid signature of some kind. Right, this would be one example check. So if you look at all of the checks that our participants did, we figured out that 4 out of those 23 checks were actually useful and could help our participants identify mails of this kind as an attack. Right, the next attack was UI spoofing, right? So this message has actually no PGP signature attached to it at all. We just put some HTML elements into the message body, right? And it gets rendered like this to mimic the actual bar that would show up on top of it. Right, so one example check to that's actually useful to identify this kind of attack would be to look for the letter icon status, right? Enigmail not only puts a bar on top, but it also put a icon next to the date there. It's missing there. If I go back to the last attack, you'll see there's a small letter icon at the top right. And if there's no signature attached to the mail at all, there's no icon at all, right? So this would be one way to spot this attack. Overall, there are 5 out of those 23 checks that are useful to spot this UI spoofing attack. What's interesting about this is if you think about the last attack, we had a very useful check of looking for a green bar that says this is a good signature. If you try to apply this check to this kind of attack, this can actually be harmful. This can be actively misleading because now you see a green bar that says it's a good signature when actually we just spoofed it, right? Cool. So the last 2 attacks, we just called them conflicting signer attacks. For these, there was just one check that's actually useful, and this is that you have to compare the sender, which is in the from header up there, which here is Bob, and you compare it to the signer, which shows up in the Enigmail bar, which in this case would be Celine, right? So this email was sent by Bob, but it was signed by Celine. This doesn't make sense. This is a way to spot this kind of attack. All right, on to the next question. Well, now, overall, how successful were our expert users in actually detecting all of the attacks? All right, so it turns out we managed to fool about half of them, which was quite surprising. So 52% of participants fell for at least one attack. If you break it down, that's 0.76 successful attacks per participant on average, with a standard derivation of just about 1. So this means that the majority of our participants either got 0, 1, or 2 emails that were able to fool them. Right. All right, we're coming to the end. What did we try to do? We set out to find an upper bound for detecting these weak signature forgeries. This is why we talked to expert users, and this is why we actively primed our participants to actively look for attacks in these emails that they got to look at. All right, so it turns out not even our group of expert users was able to spot attacks reliably. Right, this is what we found. So what now? What do we do about this? We got 2 things. One thing is short-term, right? We need to, if you want to fix this, you need to reduce the complexity of checking signatures, right? Quite obvious usability stuff. You want to have useful checks that are easy and fast to make. Ideally, you just have one simple, smart indicator element instead of like having 5 or 6 different things you have to look out for every new email that you get. All right, the other thing is about consistency, right? Right now, if you look at an unsigned email message in Thunderbird, there's no statement about the security of this email at all. And this could lead to trouble, which is why we advise that the long-term solution that we actually, if we want to increase the security regarding signed emails, right, email signatures, we have to work towards the secure way becoming the default way. Right, because if we just start throwing warnings into users' faces for every unsigned email they get, we basically lose them because they stop caring super fast. This is called warning fatigue. And you basically gain nothing from that. So, but at the same time, if you look at it from a security perspective, you have this mismatch of when warnings are shown and when not. So, like I said, for unsigned messages, there's no warnings at all. But for signed messages, messages that have a signature attached, that got invalidated by something, be it like a mail gateway that just messed with matters in some way, then you have an email and a signature attached to it. And if it's invalid, you get this huge warning. Or a red warning or something that the interface tells you that something is wrong with this email. And this is a mismatch, right? If you think about it, the email with the message attached to it is in no way more or is in no way less secure, even if the signature is broken, than an unsigned email overall. And there's this mismatch. And to solve this, we actually have to work towards and find new ways to help make the secure way become the default way in email signatures. All right, that's it. Thank you for your attention, and feel free to talk to us in the break.